Eric Burgess here. In a random sample of 260 people, 165 said that they watch educational television. Find the 90% confidence interval of the true proportion of people who watch educational television. All right, so looking at this problem, if we were to identify this, it's pretty easy to see that we are doing a confidence interval because they actually say the words confidence interval right here. So we already know we're doing one. And we want to know which kind, right? So we have Z, T, proportion, variance, standard deviation. There's all these different kinds. So looking at this, it's looking for the true proportion. So we know it's going to be a proportion confidence interval. And looking at your formula sheet, you can look at which one you need. But we always start, right, with our point estimate. And in this case, our best point estimate would be the proportion that comes from our sample, right? We did a study and we got some proportion. And then there's going to be minus some error. We'll do this using the calculator as well. And then there's going to be the true proportion in the middle. So this is how we write in the middle. And then there's going to be the proportion plus some error. And that error is written as, now proportions always use z-scores. So we're going to have z of alpha over 2. Alpha over 2 because half the alpha is going to be below and above the true proportion because it's an interval. My bad. And there's going to be the error, which is p hat times q hat divided by n. And there's going to be p in the middle. And then there's going to be our point estimate plus z of alpha over 2. It's just the error again. P hat q hat divided by n. So this is the formula we're going to need. Let's go ahead and do it with the calculator first because the calculator makes it easy as pie. Calculator requires a lot less stuff. It just wants to know the number of people that fulfill the thing that we want, which they call X. So there's this X. What is X? Well, it's the number of people who fill it. So 165 said that they watched educational television. And we want the proportion of people who watch educational television. So that's our criteria. That means that this 165 people is our X. So 165 people are the X. The total number of people that were studied were 260. This was our random sample. So we have 260 for this one. So now if we just come to our calculator here, we go to stat, go over to tests, and look for the one proportion interval. One prop Z interval. This one, A. So we choose A, and our X is 165. Our N is 260, and our confidence level is just 0.9 because that's they want to be 90% confident. And we choose calculate, and it gives it to us. That's it. It's that easy. So now what we would say is we would say, well, the true proportion, the population proportion, and it's in between two values. It's in between this lower value, 0.585. And 0.684. Now, you're rounding however many places you round to is going to be determined by your professor. And this is it. This is our answer. You would also write a sentence. So we would say the true proportion. I might spell that wrong. It's whatever. The true proportion of people who watch educational TV is between, I'm going to turn these into percentages for this, 58.5% and 68.4%. So that's what we would say. You would box this, and you would box this whole thing. So you need the top one. This is like the math way of saying it. And this is the interpretation of all those numbers and symbols you wrote, just showing that you know what that means and how we want it to be understood. So, okay, that is how you do it using good old-fashioned calculator. Let's do it using the other way, the formula. So we need to figure out what p hat is. P hat is X over N. And Q hat is just 1 minus P hat. So All right, because this is a proportion. We have the total number of people and then the people who did what we wanted for our criteria. So in this case, people who watched educational television. So that proportion of people is going to give us this p hat. It's just, that's what it would be. So we'd say, okay, 165, this is p hat, divided by 260, and whatever that is. So let's type that in. 165 divided by 260 gives us, I'm going to round to 3 places. So 0.635. Q hat is 1 minus this. So we do 1 minus our answer. So answer's here in blue. So I'm going to hit second answer. And we're going to get whatever this is. So this is going to be 0.36. And we're just going to keep it the way it is. Q hat is equal to 0.365. All right. Now that we have P hat and Q hat, we just need Z of alpha over 2. So we could use the chart or we could use the distribution. Our alpha is the opposite of our confidence interval. So our confidence interval is 90%. So that means that our alpha is 10% or 0.1. Because we're doing half below and half above, alpha over 2, that means that alpha over 2 is going to be 0.05. So we look this up in the calculator. We can use the distribution for z-scores. And we want to do an inverse lookup because we have an area and we want to find a z-score. So we hit second, distribution, inverse normal. I did that really fast. Second distribution, and then inverse normal because z-scores work on normal distributions. And we want for our area to be this area, right? Because this is the area on one side and the other. So we put 0.05. And then standard normal distributions, meaning distributions that use z-scores, are always mean of 0, standard deviation of 1. We hit enter, enter again, and we get our z-score. So z of alpha over 2 is equal to, and it's plus minus 1.64. Plus minus because the distribution is symmetric. You could find the positive case separately, but we know the distribution is symmetric. So just go ahead and use the plus minus for this. Now, if we wanted to find this using the chart, we would simply look up 0.05 as an area to get a z-score. So if we come over to a standard normal chart, and we look up 0.05, well, let's find this thing. Calculator's kind of in the way. Let's move this. All right, so we're looking for 0.05. So looking at this thing, we've got 0.09. Here's 0.05. That's pretty close. Let's see if we can get closer. 0.050 and the 0.049. So this one appears to be a tad bit closer. So we're going to use that one. 0.049. Because this is away, well, this one's away by 5. This one's requires 6. Oh, maybe we'll go with this one instead. So it doesn't really matter which one you pick. They're both extremely close. And if we come over, we are going to get the z-score that we need. And so we see that we have negative 1.64. So that's what we're going to run with. And now it's symmetric, so we can again take the positive and the negative. So we're going to have plus or minus 1.64. So we get the same thing using the chart method. Now we can plug into our formula. So our p hat is 0.635 minus our z-score, 1.64, times the square root of p hat times q hat, that's 0.635 times 0.365, there's some kind of poetic about that, divided by n, which in this case, what was our n? N was 260. 260. Our true population proportions in the middle, and it's going to be the same thing on this side, except for this time it's going to be added. 1.64. And then it's going to be all the same stuff that was in this one. I ran out of room, so I'm just going to go with that. Okay, so it's going to be the same thing. It's just on this side. The only thing that changes is there's a plus sign. So we've got 0.635 minus 1.64 parentheses. Now it wants a square root, so we put down second square root. And we want this top half to be done independently. So I'm going to put parentheses for the top proportion, top part. And then I'm going to put more parentheses for these things. This just ensures that this is done individually in the calculator. 0.635, close parentheses, open parentheses, 0.365, close parentheses. Now we close the big parentheses. So this just makes sure it's done in the correct order. And then divided by 260. And that's it. So we hit enter. And we get 0.58, which is what we got right here. Now it's a little bit different. It's 0.586. But we are extremely close. Not a huge deal. We are very, very close. It's just a rounding error. So now we're going to copy it, and we're just going to change that one symbol to a plus sign to get the other side. So we put plus, and you get 0.68, and then in this case 4. So it actually rounded to the exact same value as this one did. And this would again just be your answer. So there you go. That's how you do it using the formula. This is how you would check it. If you know about how to use fractions with this calculator, I think it's easier to input and see what's happening if you use the fraction button, but this is more common for more calculators to be able to put it in like this. If you have any questions about this, let me know, subscribe, and we will catch you in the next problem.